Okay, so the last class we are discussing about the switching operation of uh, BGT and MOSFET. We found out that we can implement logic operation using BGT and MOSFET. So one of the logic operation we learned different types of two types of logic. One of them was uh, you know not gate, which is this, and we said that not gate is a logic gate which allows you to invert the signal. So if you apply 0, you get 1 inverted. If you apply, if the logic is 1 at the input, at the output is 0. So physically, we said that it can be implemented two ways. It can be either implemented using uh, this circuit like this, consisting of BGT. So let's say RB, RC, VCC, and this is where we take our V naught, and this is where we apply the signal VI. Okay. On the other hand, if we employ MOSFET, that should look like this. So VDD, RT. In both case, if the, so let's say we apply a signal like this one, a pulse, and we get the corresponding we get. But when it's low, we get high, and when it is high, it get low value. And the value of the low, depending on the type of the device, whether it is BGT and MOSFET, it could be of different thing. So that is an this is our VI, and that is our V naught. So that is a basic uh, operation of a gate, and then we learned how to implement uh, NOR operation using MOSFET. Okay, so NOR. So this way you could use MOSFET or BGT to implement any types of gate, whether it's AND gate, NAND gate, NOR gate, or different types of gate. Now, in reality, the gates are in reality the circuit that we have. The gates are they don't necessarily use BGT or MOSFET of this configuration to implement the gate. Rather, they use a technology known as CMOS technology. It's called complementary metal. Complementary, it stands for complementary metal oxide semiconductor. Okay, so this is the technology they are in use. In fact, all the electronic devices that we have which contains semiconductor chip, they essentially use CMOS. There's a CMOS technology, and you're going to learn extensively about this topic, about the application of CMOS in your VLSI, which is EEE 411. So now this VLSI is a hot topic. I'm sure by the time you will reach that level, you will find that the demand for VLSI technology is very high. So you're going to take that course. So what is actually uh, a CMOS? CMOS. Okay. So CMOS is a combination of both N-channel MOSFET and P-channel MOSFET. So let's say the CMOS. How is the CMOS circuit representation of CMOS? We have a so this is our okay. So let me. So we have two MOSFET. One of them is P-channel MOSFET, another is N-channel MOSFET. So we have a two MOSFET, P-channel MOSFET, N-channel MOSFET. Now you can see the drain of, we call it QP, we call it QN. The drain of QP, which is P-channel MOSFET, and the drain of QN, which is also an P-channel MOSFET, they're tied together. And also tied together are the gate of, the gate of QP and gate of QN are also tied together, shorted. Okay. And then we take the output from here. So this is where we apply the input Vi. So that is CMOS. So we have both N-channel MOSFET and P-channel MOSFET integrated or constructed on the same silicon substrate. So that is the CMOS. Now, as for not get implementation, we're going to use the following circuits. What I have got already this circuit. Okay. All right. So that is this is the circuit for the time being. Just get rid of those. Okay. So that's the circuit. So this is a NOT gate. This is a circuit diagram for a NOT gate or inverter using CMOS circuit. Okay. So what do you have here? The source terminal of P MOSFET is connected to a DC voltage source of V plus 2.5 volt. Source terminal of N MOSFET is connected to a DC voltage source of minus 2.5 volt. And output is realized against a load resistance RL 10K. Okay. This is where we apply the input signal. This is where we apply we obtain our output signal. What is said? Both the MOSFET QP and QN, both of them are matched. What does it mean? They are Kn value and Kp value, they are same, which is equal to 1 milliampere per volt square. And also, their threshold voltage Vtn is minus Vtp equals to 1 volt. So threshold voltages are also same. They're absolutely matched. Okay. So these are the parameters for both the MOSFET, P channel MOSFET and N channel MOSFET. What do you have to determine? We have to determine the V naught outset for Vi equals to 0 volt, then 2.5 volt, and then minus 2.5 volt. For three values of voltage, we need to determine the output. Okay, let's start this case one. The case one. Case one. Vi equals to 0 volt. All right. Okay. So let's redraw the circuit. So Vi is equal to 0 volt means it is connected to the ground, short circuit, inputs short circuit. Right. So this is the circuit looks like after Vi is equal to set to 0. Now we have to deal with two types of MOSFET at the same time, QP and QN. One of them is N channel MOSFET, another is P channel MOSFET. So in both cases, we follow the same steps. Fortunately, I have these things written down. Case one, check. Check. First step, as before, check if channel is or not. If channel is induced or not. Check if channel is induced or not. For QP, first of all, let's do it for QP. What do we do? Same thing. There is nothing new. Whatever the things I'm doing here, we have done. There is nothing new in that. We did what? We know we do VGS. So VG minus VS equals to VG is equal to 0 volt minus VS is equal to what? Of koto? 2.5 volt. So clearly it's less than VTP. আমাদের VT কত? VTP কত? VTP is equal to -1. VTP -1. So it's less than VTP. So channel induced. Channel induced. Okay. We do the same thing for QN. VGS VG minus VS. VG got again 0. What is VS? VS is equal to minus 2.5. So minus 2.5 minus 2.5. Again, it's greater than VTN. VTN is 1. So again, for both cases, we find channel induced. So it means neither QP nor QN are operating in the cutoff region. Both of them has channels. So we know that what if channel is induced, there are two possibilities. Either the MOSFET is operating in saturation region or in triode region. We don't know. For that, what should we do? We need to do VGD. So do VGD, which is VG minus VD, which we know VG is equal to 0, but we don't know VD. We don't know VD. So in that case, what I'm going to do? I'm going to assume saturation for both MOSFET. Let's do it for Q1. Okay, Q1. I want to determine current. So if for saturation reason, so IDN, let's call the IDN. Let's say the current that are flowing. Let's say the current that are flowing is IDN, okay, and in the P channel, it is IDP, and then IDP. Okay, so P channel, the drain current is IDP, which is flowing from source to drain. N channel, the drain current is IDN, which is flowing from drain to source. So that's how it is. So what is IDN? For N channel, we know the expression for current Kn VGS minus VTN whole square, all right, which is what? 1 VGS হচ্ছে VG minus VS, VG কত 0, VS কত minus minus 2.5, so 2.5, so 2.5 minus V10 হচ্ছে 1 whole square, that gives us 2.25 milliampere. IDN is equal to 2.25 milliampere. Okay. So similarly, what is the current for QP? IDP, which is KP VGS minus VTP whole square. You see, there is nothing new. You just remember the steps we followed to solve the MOSFET circuit, considering the MOSFETs are operating in saturation region. So again, what is KP? 1 milliampere per volt square. What is VG? VG is equal to 0. VS is equal to 2.5. So minus 2.5. What is VTP? Minus 1. So minus plus. Again, we get what? 2.25 milliampere. So what is our finding? Our finding is that IDN equals to IDP, and both cases are same, 2.25 milliampere. Okay. এখন তো আমরা পেয়ে গেলাম। আমরা কি করেছিলাম? We assume that the MOSFET is operating in saturation. For that, we need what? We need to go do VD. So I need to determine whether our assumption is right or wrong. For that, I need to determine VD. How can you determine VD? Look at that. If you notice here, VD and V naught are same point. So VD is equal to, VD equals to V naught. Okay. Now, when it comes to V naught, how can you determine V naught? So again, if you do KVL from ground up to that point, considering the current that is flowing is IL, let's say the current flowing is IL, তাহলে আমাদের V naught কি? V naught should be IL RL. Okay. Now the question is, how can we determine IL? So for that, if you notice the current, the current flowing here at node D, we have one incoming current, what is IDP, and two outgoing current, what is IDN and IL. So we can write applying KCL. So KCL at D, we get IDN, IDP, which is the incoming current, equals to IDN, which is the outgoing current, plus IL. Now you already know IDN and IDP are same. So IDP, IDN, they get cancelled out. So that gives us IL equals to 0. No current is flowing through this resistance. That means, so whatever the current the first MOSFET is sending, all the current goes through the second MOSFET. There is no current flowing through the RL. What does that mean? V naught is equal to what? VD is equal to V naught is equal to 0 volt. So that means if I do VGT, which is we get 0 minus 0, which is 0 volt. VGT 0. এখন VGT 0 মানে কি? So verify for Q1. For Q1, if you do VGT for Qn, VGD equals to 0 means it is less than VTN. VTN আমাদের 1, তাই না? So no channel exist. Where? At the drain end. So our assumption is right for the N channel message. What about P channel message? For QP, for QP. Again, same thing. Actually, same thing. Let me just borrow it from here. Just in that case, it is greater than VTP. VTP is -1. So -1, 0 is always greater than -1. So no channel access the drain end. So for both Qn and QP, both the MOSFETs are operating in saturation region. Both the MOSFETs are operating in saturation region. তাহলে our assumption is right. That means when Vi equals to 0 volt, then output V naught is equal to, so there is actually no logic. তার মানে হচ্ছে আমরা 0 জন্য 0 পাচ্ছি, 0 জন্য 0 So this is our case 1. For case 2, first of all, Vi equals to 2.5 volt. Let me bring our circuit থেকে নিয়ে আসছে. Okay, first case. So this is the circuit looks like. Ki Vi is equal to 2.5 volt. This is the circuit looks like. Just give me a second. I'll be back in this. All right. Same steps. Again, so we have input voltage. Previously, it was Vi is equal to 0. Now 2.5 volt. Same process. Check EVJ. I'm just, make it. Um, so uh, that part I just borrowed from here. For QP, we do VGS, VG minus VS, VS is 2.5, VGS also 2.5, 0. So 0, which is greater than VTP. VTP is equal to কত? VTP হচ্ছে আমাদের VTP minus 1 volt. So that means no channel induced, cutoff is an IDP is equal to 0. We do the same thing for QN, VGS, VG minus VS, 2.5 minus 2.5 channel induced. Okay, so we have got one, we have channel induced, another one. So here IDP is equal to 0. So that means what I can do, so I can, in fact, this circuit, modify the circuit like this. Okay, so the P MOSFET, as if it doesn't exist. It doesn't exist. It doesn't exist. It doesn't exist. So circuit looks like this. Okay, so the circuit looks like this. এটাকে আমি একটু সিম্পলিফাই করে, সিম্পলিফাই মানে হচ্ছে, so it looks like this. So I can represent this in terms of this. That is how it should look like this. Okay, so VI is equal to 2.5. What? This is our source. Source is connected to minus 2.5. You see, notice drain is connected to RL 10K. Drain is connected to RL, which is goes to the ground. Our V naught is where this is where we get our V naught. At that stage, again, we're going to, we already know channels exist. At that step, we are not, since we are considering a not get, we are going to consider that it is operating in triode region, the MOSFET triode region. এই ক্ষেত্রে আমরা আগের মতো যেরকম এজিউম করেছিলাম, এখন আমরা এজিউম করব না, সরাসরি ধরে নেব triode region. Okay, if it is operating in triode region, then what is the current expression? ID n equals to Kn to VGS minus VTN times VDS minus VDS whole square. Okay. So which we already know, we need to find two expression for ID. Another expression is what? And that is our, if this is our IDN, IDN. Okay. So what is another IDN? IDN can be written as 0 minus VDN. So VDN or divided by RL. You can write as 0 minus VD divided by RL. So that can be written as 1 2 VGS হচ্ছে আমাদের 5, 2.5 minus 2.55 minus 1, আর VTS হচ্ছে VD minus VS. minus again Vd minus Vs whole square minus Vd divided by RL. ওকে, এখন আবার আরো করি 8 times what is Vd? Vd তো unknown. Vs আমরা জানি, Vs কত? minus 2.5, so plus 2.5 minus Vd minus plus 2.5 whole square equals to minus Vd divided by 10. So we end of the day we're going to get a quadratic equation of the type we already obtained before. So আমরা কি করব? আমরা Vd পাবো। So Vd পড়লে আপনারা জানেন Vd এর আপনারা in fact in that case probably you're going to get value of Vd. It should be something like 2.44 volt. That's what you're going to find. Okay. So Vd পেয়ে গেলাম, that is our in fact V0. V0. Again তাহলে দেখি এখন কি ইনপুট কি ছিল? So input ছিল Vi equals to 2.5, V0 is equal to minus 2.44 volt. So that is our case 2. So that's case 3. Where Vi equals to minus 2.5 volt. Okay, so let's get it from there. Okay, this is when Vi is equal to minus 5. Minus 2.5 volt. আগের মতো করি, we're going to do check EBJ. আমি এখন আর করব না, check EBJ করলে we're going to find out QP for QP VGS QP channel induced and QN you will find out that's not induced. So ওই সার্কিটটাকে আমি যদি ড্র করি removing, so the final circuit looks like this. Okay, আমি এখান থেকে আচ্ছা ঠিক আছে এটাই দেখাই। Okay, so lower part is gone. You can say the lower part gone. ID 0. Okay, you can say it looks like this. And this is our Vi minus 2.5 volt. এটাকে যদি সিম্পলিফাই করি it will look like this. এটার মতো দেখাবে। Should look like this. Okay. This is our IDP. This is our drain VD. Drain VD. Okay. Same step. Triode region. If you consider triode region, আমি এটা এখান থেকে নিয়ে আসি। So KP VGS minus VTP VDS minus VDS whole square, VD divided by, so in that case, VD divided by RL equals to VD divided RL, which is, and after doing all those things, we get VD is equal to 2.44. তাহলে আমি যদি একটা টেবিল তৈরি করি, let's say, let's make a table. VI, V naught, number one. So 2.5 volt, we get output is minus 2.44 volt. 0 volt, 0 volt, minus 2.5 volt equals to 2.44 volt. তাহলে লজিক লেভেলটা যদি দেখাই, in that case লজিক লেভেল আসলে এরকম 2.5 থেকে মাইনাস এরকম. So logic level, let's say around 2.5 to around minus 2.5 or 2.44. So 0 জন্য 0, এটা হচ্ছে ইনপুট, আর আউটপুট হবে করেসপন্ডিং, সরি, minus 2.5 থেকে minus 2.5 থেকে minus 2.5. So that is how we can implement inverter using circuit. Okay. Any question? Any question? Okay. So I have couple of announcement to make. One of them is that so you have to, so I think I have posted this thing. Let me check in Google Classroom. It is, okay. Assignment 1, you have those who have submitted. So listen to me very carefully. Those who have submitted the soft copy online, within the time, you have to submit the hard copy. It is mandatory for me to submit the hard, for you to submit the hard copy, because I'm going to grade the hard copy. So in case you miss the hard copy, I will not be able to submit the, I will not be able to grade you. And you have to submit the hard copy, either the work, exact the same work. It cannot be, updated work. No, you are allowed to update the work. So that's why I would encourage you, you use the hard copy from which you prepared a soft copy, either this copy or take a print of the soft copy and submit it by Wednesday. If you want, I'm not in my office. If you want, if you bring your hard copy today, you can go to the department, talk to the office assistants, and then tell them, hand it over to them. বলে দিবেন যে বেলাল স্যারের রুমে রেখে দেওয়ার জন্য, ওখানে সাবমিট করতে পারেন। Otherwise, you have to submit it by tomorrow and day after tomorrow. I am not going to. Yes, মেহেদি জামান বলেন।
স্যার আমাদের কি ওয়েডনেসডেতে নরমাল রুটিনে ক্লাস হবে?
No, normal routine না, Thursday routine.
ওকে স্যার।
ইউনিভার্সিটি যেটা বলেছে থার্ড, সো ওয়েডনেসডে আমাদের ক্লাস, আমি পরে আসছি এটাতে। ঠিক আছে, এক নম্বর হচ্ছে আপনাদেরকে হার্ড কপি অবশ্যই সাবমিট করবেন, and the same copy that uh, that you submit in the soft copy. Uh, anyone, uh, if you fail to submit your soft copy, please don't send, then don't give me the hard copy. আপনি যদি সফট কপি সাবমিট মিস করে থাকেন, I'm not going to grade your hard copy, so please don't submit it. One thing. Second thing, I have reassigned, assigned those who couldn't find any group in the Google sheet. So you can find your group now. Start working on the design project. Next Monday, I think we're going to follow another Thursday routine. So Monday, we're not going to have any class. Okay, but our last class will be held on uh, Wednesday, which is 7th of, yeah, so it's the 7th. On 7th, we're going to take our last quiz. The quiz will be on BG switching analysis of the BGT and MOSFET. তার মানে হচ্ছে লাস্ট ক্লাস এন্ড আজকের ক্লাস। লাস্ট ক্লাস বলতে সুইচিং এর যে লাস্ট ক্লাস প্লাস আজকের ক্লাস মিলে যে টপিক, এই টপিকের উপর আমি নেক্সট ওয়েডনেসডেতে আই এম গোইং টু টেক আওয়ার লাস্ট কুইজ। ওকে, দিস টু। And third is that this Friday, which is 2nd of February, we're supposed to have our makeup class. One of the classes that we missed for during the midterm exam, the convocation for and others, we missed that class will not take place. You can consider the tutorial class or the makeup class we took on Thursday, last Thursday. You can consider this is the makeup class. So এই ফ্রাইডেতে আমাদের কোনো ক্লাস হবে না। ইয়েস, আশরাফুল ইসলাম ইমন।
স্যার এই ওয়েডনেসডে কি ক্লাস হবে না?
এই ওয়েডনেসডে তো আপনারা কি ইউনিভার্সিটি থেকে কোনো নোটিশ পাননি?
স্যার আমার তো মেইল পাইনি স্যার।
আপনারা মেল পান?
স্যার
ইউনিভার্সিটিতে কোনো মেল
অন্য
পাচ্ছেন না?
সেকশন,
কথা হলো
অন্য সেকশন থেকে, মানে অন্য সেকশন থেকে বলছে, বাট ভার্সিটির মেইল তো দেয়নি কিছু।
ভার্সিটির মেল
মেইল
দেয়
কি?
নাই। ভার্সিটি আপনার ক্যালেন্ডার ফলো করবেন। মানে এই
ও
এই
আচ্ছা আচ্ছা।
নোটিফিকেশন কিন্তু আমাদের দেওয়ার কথা না। আমি 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 দেখবো হচ্ছে ইউনিভার্সিটির নোটিফিকেশন। আমার এই ক্ষেত্রে আমাকে সেপারেটলি কোনো নোটিফিকার কোনো স্কোপ নাই।
আচ্ছা আচ্ছা।
ইউনিভার্সিটির নোটিফিকেশন যেটা সেটাই হবে।
আর স্যার যেটা অ্যাসাইনমেন্ট, ওইটা কি যেটা সফট কপি জমা দিচ্ছে ওটা প্রিন্ট করে দিলে হবে? আমি মেইন কপিটা খুঁজে
ওইটা
পাচ্ছি না।
ওইটা দিলেই হবে। ওইটাই
আচ্ছা
আমি
আচ্ছা
এনকারেজ করছি।
আচ্ছা।
আপনারা যদি আজকে থাকেন আজকে দিয়ে দিতে পারেন, কালকে অথবা পরশু। আপনারা যদি ইউনিভার্সিটি আজকে থাকেন, যারা আছেন প্রিন্ট করে আজকে সাবমিট করে দিয়ে দিতে পারেন। আমি নাই, কিন্তু আমাদের অফিসের সিস্টেম কাছে লিখে সাবমিট করে দিতে পারেন। ঠিক আছে। আর ইয়া, আর রামিসা তাবাসসুম।
স্যার কুইজের সিলেবাসটা কি কাইন্ডলি আরেকবার একটু বলবেন?
হ্যাঁ, শিওর। বিজিটি এবং মসফেট সুইচিং অ্যানালিসিস প্লাস আজকের ক্লাস, এটাও তো সুইচিং পার্ট। আচ্ছা, আপনারা যারা নোটিস পাননি, ইউ আর সাপোজ টু গেট নোটিফিকেশন ফ্রম দ্য ইউনিভার্সিটি দিস ওয়েডনেসডে এন্ড নেক্সট মানডে। বলেন তো কি হবে, যারা জানেন?
থার্সডে রুটিনে ক্লাস হবে।
থার্সডে রুটিনে ক্লাস হবে। স্যার
Thursday
মেল দিছি।
routine will be followed this Wednesday and next week Monday. Thursday routine will be followed. So that means we are not going to have any class on 205. And the last class, which will be on 7th of January, I am going to only take the quiz. Effectively, we are done with our syllabus. I am going to take the quiz, plus I'm going to discuss about the final exam pattern and others. Okay, so make sure don't miss that class. Okay, so I'm going to call you name for attendance.